In today's lesson of application of differentiation, we'll be looking at comparing rates of change. We could apply differentiation in comparing rates of changes. If we have a function in x, say y is equal to f of x, the rate of change of y will be given as dy dt, and also the rate of change of x will be given as dx dt. There's a relationship between dy dt and the x dt, and this relationship is given as dy dt is equal to dy dx times dx dt. This relationship that holds the rate of change in y as compared to the rate of change in x. Let us see how we use the relationship to compare rates of changes. Now look at these examples. At what rate is the area of a circle decreasing when the radius is 4 cm and is increasing at the rate of 0.2 cm? First, we have to get our relationship. Solution. We know that area, let's say A is area of circle, and this is given as pi r squared. Then the rate at which the area is decreasing is the a dt, and that we do not know. But we know that our dA dt in the relation given up above is something as the a dr times dr dt. Let us start giving our parameters. Our radius, which is r, is equal to 4 centimeter. The rate at which our radius is decreasing, the rate at which our radius is increasing, is given as 0.2 centimeter per second. So also the a dr is equal to 2 pi r. So our dA dt, which is given as 2 pi r times 0.2 centimeter per second, will now give us 2 into 4 centimeter into pi times 0.2 centimeter per second. This will give us 2 times 0.2 centimeter per second times 4 centimeter times pi. That will give us 1.6 pi centimeter squared per second. So the rate at which our radius is changing is equal to 1.6 pi centimeter square per second. That is our answer. Here we have another example. It says an ink blot, which is also an area, has a radius of 12 millimeter, and its area is increasing at the rate of 3 millimeter square per second. At what rate is the radius increasing? That is our question. The rate at which the radius is increasing. Solution. Our area, our A, is area of ink blot, which is pi r squared, and our radius r, which is radius, is equal to 12 millimeter. Our change in area with respect to the change in radius, the ADR, is 2 pi r. Now the question says we should find a rate at which the radius is increasing, the r, the t. We do not know, but we know that the a, the t, from the equation given above, is the a, the r, times the r, the t. And we were given the a, the t as 3 millimeters squared per second. So this will become 3 millimeter squared per second is equal to 2 pi r times the r, the t. Therefore, the r, the t will give us 3 millimeter squared per second over 2 pi r. This will translate to 3 millimeter squared per second over 2. Our radius is 12 millimeter pi, and this will give us 3 millimeter squared per second over 24 millimeter pi. This will give us 1 millimeter per second over 8 pi. So the rate at which our radius is increasing is equal to 1 over 8 pi millimeter per second. This is our answer. Our next example says a circular cylinder has a radius of 0.3 millimeter and it is being filled with water at the rate 0.009 meters cubed per second. Find the rate at which the water level is rising. Actually, the radius is 0.3 meter. Now, before we solve this, I want us to have an idea of what a cylinder looks like. We have to picture this at the back of our mind. This will draw here. Now, this is our cylinder. And the question says that the radius, this is the radius r, and this is the height. What is changing here is the volume of the water. What is changing is the volume of the water. The water level is increasing. It could change something like this to this as water is being filled, as the cylinder is being filled. So let us start. We know that the volume of a cylinder is equal to pi r square h. In this particular relation, we say where V and H are variables. What this means is that pi and r are constant. So we differentiate our V and we differentiate our H. So when we differentiate, the V, the H will give us pi r squared. And they told us that the radius is 0.3 meters. And the volume is changing at the rate of 0.009 meters cubed per second. So our question is to find the rate at which the water level is rising. We'll go to our relation again. dV dt is equal to dV dH times dH dt. So we say 0.009 meter cube per second is equal to pi r squared times dH dt. Our 0.009 meters cube per second is the rate at which the volume is changing, and pi r squared is the differentiation of V with respect to H. So the H dt will give us 0.009 meter cube per second all over pi r squared, and this will give us 0.009 meter cube per second all over 0.3 meters all squared pi. This is equal to 0.009 meter cube per second over 0.09 meter square pi. This is equal to 1 over 10 pi meter per second. So the rate at which the level is increasing or rising, dH dt, is equal to 1 over 10 pi meter per second. This is our answer.